Hey, can you tell me a bit how the module is working?
Sure. So the roombot's module is made from 4 half spheres. We print all of them in plastic. And so basically you have these 4 half spheres here or here. And you're going to have 3 degrees of freedom in the middle. So this is 1, 2 and 3. And what you can see a little bit from the drawings and also from here, we implement a planetary gearbox and pretty standard motors in addition. So we have 2 stronger motors in the outer half spheres and not so strong motor in the middle. So basically the middle joint is not as strong as the outer ones. The reason why we made our own half spheres, our own gearboxes, is that we needed to have a continuous rotation that helps us for the reconfiguration of for the roombot's modular robotic part. So basically we can have 360 degrees and continuous rotation, and for this one we needed to have the ability to basically have signals, electronic signals and power going through the joints from any half sphere to any other half sphere. So hence we made our own gearbox system such that we can use slip ring technology to put the wires through. So basically we have 3 degrees of freedom, so the main actuators, and in addition we're gonna have the active connection mechanism, what you see here. So you see looking out 4 grippers. This mechanism is rotatory symmetric in 4 degrees, so you can have 90 degree symmetry. So basically you can connect any other module in 4 different ways, and the whole roombot's module has theoretically up to 10 possibilities to attach the active connection mechanism. So again, we made this ourselves, so we have a little standard motor and then we have a little gearbox system what basically distributes it such that we have a specific movement for the plastic grippers, so they're pretty strong. We will exchange those plastic grippers in the future by FR4 material, so by PCB material, such that they have also the possibility to supply other modules with energy. So basically we have technology that will transfer power via the grippers later on, so we can share energy between the modules. What else to say? Well, main technologies what we're using here at the EPFL is 3D printing with ABS plastics, so like all the outer pieces. We use a lot of PCB material. This is glass fiber reinforced plastic, and then I try of course to use as many standard pieces as possible because it's much easier and in the end also cheaper. For simplifying the work a little bit with the roombots, we have built mock-ups. So basic idea is the same degrees of freedom, but instead of having an actuated version, we just have a version what can passively turn. It has a latching mechanism, so a ratcheting mechanism, so it's being blocked a little bit by an internal spring system. And instead of the active connection mechanism, we are using magnets. So we use the system such that the magnets don't have basically a north and south anymore. So you basically can connect any other mock-up to any of the sides, and this gives us the possibility to basically test in advance what type of movements are possible, and it gives the haptic feedback for building, for example, passive pieces or building pieces for furniture. We also used it for testing the range of motion for quadrupedals. So it's a nice tool to interact a little bit with the roombots in advance, and it's not as expensive as you would already, and it doesn't take so much time to develop those things.